Oh my God, it's live. Oh, no, where'd you go? Where'd you go? I want you back. Okay, while we have time and energy, we should probably get to this number 4 question. No, let's do number 3 and then number 4. Okay. We didn't finish 8.
Oh, yeah, 8.
All right, we're here, right? Okay, so we did the. There we go. We're here, right? Okay, so insert more room. Let's see. You see insert space? Thanks. You see insert space? Really? Yeah.
Are you saying like calculus diagnostic test?
No.
Sorry, bonehead, you're going somewhere else. Oh, yeah. You're gonna call that, you know. You do that.
Okay, derivative with respect to t, right? Derivative of 5.7 with respect. Huh? Well, it makes no sense not to record sound, right? His name is yeah. Derivative of the left side 5.7x minus just this minus 14.3y. That's going to be the derivative with respect to t of 0. Great. Okay, derivative of 5.7x is 5.7 dx dt. Minus the derivative of 14.3y, that's 14.3 dy dt. I think my decimal point got swallowed. Equals 0. Okay, so I don't remember what the diagram looks like. Do we know dx dt or dy dt? You know dx dt. She's moving toward the light at a rate of 5, right? Now, this isn't going to matter a whole lot in terms of the answer, but I like putting it in there because it really needs to be like this. Is x shrinking or is x growing? It is shrinking. So technically speaking, if a quantity is decreasing, getting smaller, that derivative should be negative. Equals negative 14.3 dy dt. It is positive, you're right. And you know, at this point, it doesn't really matter. You're done, whatever that answer is. If you want to give me a number, that'd be cool too. Negative 28.5 even? That doesn't look good. No, I see what you're doing. 14.3. 1.993. Okay, so we have a rate that's negative. You want to contextualize that answer. So this is Alexis. Alexis graduated from UCLA like in the spring. It's weird. She's been on this review sheet now for 6 years. Weird. She got a job at the Skirball. If you get a Skirball, you can see Alexis. Or not. She's like in the offices or something. Alexis is walking toward the light. At a rate of 1.993. You don't need the negative there because you are indicating direction with your sentence. Oh shoot, yeah, why is there shadow length, right? I totally messed that up. Why is the shadow according to my diagram? Totally messed that up. So let me rewrite that. So the shadow is shrinking, right? Shrinking. At a rate 1.993. That feet per unit of time. Second. My handwriting is ugly. Not good. All right. Questions? Yeah.
It says that she's 10 feet away from the base of the light.
Mhm.
Is that not necessary?
Yeah, it turned out to be not necessary. You say that the best way to mess up a student who knows some math is to give them a lot of unnecessary information.
Is that what they do on the AP test somewhere?
No, not really. But that's what they do if you actually go out and do math. All sorts of unnecessary information and missing information. Just a thought. This is 5 over here. No, this is, what is a parabola problem? Oh, it is 5. So this is a parabola problem. We started this during period something. 5, thank you. During period 5, we were looking at this parabola problem, and let's see. We have that point at 3, 3.5. We have that parabola at y equals negative x squared. We can plot that point, and we can kind of guesstimate where that shortest length is. That shortest length is the one that you see in blue. So we have an idea that the shortest link should be in the fourth quadrant, but as far as x coordinates and its y coordinates, it should be unknown. Okay, so what happens next? Well, what is the distance between an unknown point x, y, and the point 3, 5? Just use the distance formula here. No problem. And that's what we want to minimize. We want to take our derivative, and so rather than take the derivative, I think it was this class, someone said, why don't you square both sides first? So I squared both sides first before I took the derivative. And that actually turns out to be a little bit easier to do than trying to use a chain rule in this case. So just to kind of give you that indication that the chain rule may not always be the best way to go. Sometimes you want to not solve for the variable you're finding a derivative for. Okay, so f squared equals x minus 3 squared, y minus 3.5 squared, and here's what I'm wondering. Yeah, this is where the big oops happens. Okay, so before we took the derivative. I know I showed you the derivative already, but before we do that, we notice that y equals negative x squared. If that point is on the curve y equals negative x squared, then the y coordinate should be related to the x coordinate by negative x squared. And that's great because now you can substitute here, instead of y, you're going to have negative x squared. Perfect. At this point, now I'm going to square it again. And we'll get to this one right here. I don't know why I did this, but I mean, I know why I did this, but I don't know why I didn't write it more explicitly. Does everyone see that negative 1 squared? Are you wondering where that came from? There are yeses and nos. Okay. Notice here we have negative quantity x, sorry, negative x squared minus 3.5 squared. It's really difficult not to have the pens up here. We've got negative, let's do this on the side, negative x squared minus 3.5 squared. You can factor out that negative 1, right? So that becomes negative x squared plus 3.5 whole thing squared. Whoa, what just happened? And then I think you see really easily from there that negative 1 kind of cancels, and it's the same thing as this right here. Good. Okay, now what do we do? We scroll the correct way. Simplified here, derivative here. I'm going to write that line there, the derivative part. That was weird. Right, so I moved the wrong part down, didn't I? Interesting. All right, I'm not going to write it. Any questions on the derivative part? Derivative of 2f is 2f df dx. Derivative of x minus 3 squared, 2x minus 3 squared. We don't need a dx dx because that's 1. Derivative of 2 times this quantity is 2 times a quantity times the derivative of a quantity over here. And finally, solve for df dx. That's my df dx right there. Last step here, of course. We had an equation for f. We did. We had an equation for f. F was that was a Roomba. Back in. Error. X minus 3 squared plus x squared plus 3.5 squared. That was my equation for f, right? Okay, we're going to have to set that equal to 0. Well, no, we're not going to have to set that equal to 0. We're going to have to set the numerator to 0, and we're going to have to set the denominator equal to 0. So, question, yeah. From that blue thing that we did earlier, when we simplified, that over here. Okay, so let's get our calculator. Let's find our critical points. Yeah. Mm-hmm. Well, interesting. The denominator. Now that when you could just set the derivative equal to 0, but it's actually easier if you dissect it into parts because the derivative won't be equal to 0 unless the numerator is equal to 0. So really the denominator, regardless of what the denominator is going to be, the numerator has to be equal to 0 for the derivative to equal 0. We got to find that point.
X2 minus x1 squared plus y2 minus y1 squared is d squared, and then take the derivative of both sides and set the left side equal to the right side. And you equal to 0.
That's what we're doing.
Given that I squared up those two, and then I didn't have a denominator. I got the right answer.
You should have had a denominator. Check your work. Make sure you did the chain rule on the left side.
I did the chain on the left side, and then the whole left side, or the whole d side is equal to 0 because it's constant.
The distance isn't constant. The distance changes with respect to the value of x. Okay, we should be setting that denominator equal to 0 to find a critical point. I don't know if you'll find one. You should be setting that equal to 0 as well. Okay, so let's get do we get a number for x? So glad you guys brought your calculators today. 0.363. And this one, I believe, doesn't have a root, yeah? No. So we need to check to see if this is a relative minimum or a relative maximum. I don't think you want to take a second derivative here. No? Probably not. So let's do our first derivative chart. Here's our first derivative test. Negative infinity to 0.363. 0.363 to positive infinity. That's our value of x. We want to calculate our slope. Sorry, f prime. Okay, so a number between then and there, negative infinity to 0.3. I think 0 works nicely, right? If I substitute 0, I get 0, 0, negative. My denominator is a square root, so my denominator should always be positive. Excuse me. So that indicates to me that we have a negative there. Some number between 0.363 and infinity. Yeah, 1 would work, but I think you'll have a better idea if you put in 100. 2 times 100 cubed plus 800 minus 3. Is that positive or negative? Positive. Yeah, no math required if you put in a ridiculous large number here, okay? All right, so that's a positive number. So it looks like we got a minimum, right? We have a minimum at x equals 0.363. And how do I get that y coordinate? Yeah, y equals negative x squared. This off to the side, let's compute that. Y equals negative. And a good thing to think about now is if I just squared 0.363, I'll probably get the y coordinate wrong. Because 0.363 is not the answer to the y coordinate. So I'm going to need more digits there. How many digits should I put? Maybe 2 more? What are the next 2 digits? 0, 0, 3? Thanks. Point 1 something? There's a 0.09. Or am I way off? 1317? Great. Great. Which brings up the point, as long as you're correct to that 3rd decimal point, it doesn't matter what you write after it. Okay. It's still going to be marked correct as long as those first 3 decimals are correct. So if I had wrote negative 0.1319, actually the AP test would mark that correct. I don't know if I'd mark it correct, but the AP test would mark negative 1.1319 correct. Yeah. Yes. Okay. Questions on number 5? Perfect. This is a problem. I don't think we're going to be able to get through as much as we need to get through today. That would be a shame if I had to postpone the test. Damn shame. I think we want to do the ones on after the renumbering. I think we want to start there. Let's start with the snow cone, number 3. The second number 3 on the back side. You're eating a delicious snow cone. From POG is a diluted water mixture that rises to a height of 3 inches from the bottom of the conical shaped container. The container is 6 inches tall with a diameter of 4 inches, and you notice that there is a leak and calculate that, who does this? Calculates that the cone is draining at a rate of half a cubic inch per minute. Yeah. You're right, that rate would definitely increase. Write a function for the volume of the liquid in the cone in terms of height. FR3. Okay, so let's get ourselves an ice cream cone. No, snow cone. Snow cone. Pretty good looking cone. We have, what is that diameter for or radius of 4? Diameter is 4, so don't really care about the diameter, do I? Radius is 2, the height is, was it 6? The height is 6. That's great. Height is 6, and we have stuff in our cone. I'm gonna make the stuff in our cone red. Like it's blood. We got blood inside of our cone. Not pleasant. Okay, so there's my POG. Do I know the radius of the POG juice? No. Is it constant or is it changing? It is changing. It is changing. So we'll call that R. How about the height of the POG juice? Is that? It's changing. Okay. Did you figure out that these two cones were similar? Good. Give me important ratio. How about radius to height equals radius to height? Now, I really don't care about the radius all that much, do I? I really care about the height. So I'm going to say that the radius equals 1/3 of the height. At this point, someone else always asks, why is it 1/3? So if you need to do that, I'm going to turn around and you can ask someone right next to you, okay? Okay, good. Good job. Good job. So we all know, and it's a cone, so the volume of the cone is 1/3 pi r squared h. Someone's also going to ask if you need to memorize that formula. The answer is yes, you need to memorize that formula. Someone's also going to ask, which formulas do I need to remember? And the answer is as many as you can. Okay. All right, radius is 1/3. Let's substitute that in. Volume equals 1/3 pi h squared. So that 1/27th h cubed, the volume equals pi over 27 h cubed. Hey, that's the answer to letter A. Sorry. There's A. Great. Currently, how much liquid is left in the cup? I just have this handy volume formula. Why don't I use that, right? E. Currently, the height is, what was the height? You said 3? So currently the height is pi over 27 times 3 cubed. 3 cubed is 27. So we have pi. Cubic inches, right? That's a respectable looking pi. Oh yeah, sorry. Once you get the volume formula, the rest of this seems pretty easy, right? C. Give an equation for dV dt, the rate of change of the liquid, the volume of the liquid. So d dt of the volume equals d dt pi over 27 h cubed. Derivative of the left equals the derivative of the right. dV dt equals pi over 9 h squared dh dt. We don't have that many scissors. Just that. Okay, any questions on C? Great. All right, so D, we know the volume is decreasing at a rate of half a cubic inch per minute. H is currently, did you say 3? I think that gives us DHT of pi halves, right? No, 1 over 2 pi.
Problem like this, volume in this case is technically in respect to only one variable, we still have to do like.
Yeah, because we're if you take a look at all the rates that you have, everything is per minute. Per minute. That tells you that your derivative is dt. Is dt. Okay, that's 3. Any questions on that? And I really feel like you aren't ready for this. Really don't want to put it on to Tuesday. It's going to be horrible if I put it on Tuesday. You're going to be really bad. So you get to decide for period 5. You should know right now that if we go on Tuesday, people are going to suffer. You may not think they're going to suffer. Grades are going to go down. Not those of you who are going to study. Those of you who are not going to study. Your grades will suck horribly. Tuesday's a short tour. I'm sorry, that's the deal. I'm not making the test shorter too. So this is your devil's bargain, right? Tuesday, okay, it's gonna be tomorrow. It's gonna be for Tuesday. Tuesday is a short day. You will be here the whole period. Tomorrow.
I'm like, you know, it's not this way.
The other thought, maybe.
What if we do a different?
Here's a thought. Here's a thought. What? Maybe I should not record this anymore. Stop sharing.